Shortcut technique of bending moment for external applied moment. This is our sign convention for bending moment and shear force. This is external moment m0. This is applied point. Let us see the shortcut technique. Bending moment diagram jump at external moment applied point. Here bending moment diagram jumped, suddenly jumped. If clockwise moment, bending moment suddenly increased by that value when consider LHS to RHS. That is, this external moment clockwise direction, then this LHS bending moment value suddenly increased by that particular value to RHS bending moment value. Here jump by m0 upward. If anti-clockwise moment, consider anti-clockwise moment, bending moment suddenly decrease by that value when consider LHS to RHS. That means if anti-clockwise moment, LHS bending moment value decrease by that particular value to RHS bending moment value. Question: cantilever beam with external moment. Shown in figure, draw the shear force and bending moment diagram. Firstly, find the support reactions R and M. Total upward forces is equal to 0. Therefore, R is equal to 0. There are no loads. Take moment about this point A. Consider clockwise direction positive. M clockwise moment, therefore plus 20 anti-clockwise moment, therefore minus 20 is equal to 0. M is equal to plus 20 kilonewton meter. R is equal to 0, M is equal to 20 kilonewton meter. Reaction 0, load 0, therefore shear force diagram 0 and 0 area also. Bending moment diagram, here clockwise 20 kilonewton meter, therefore plus 20. Here area 0, therefore plus 20, plus 20, plus 20, plus 20 up to here. Here anti-clockwise external moment, therefore minus 20. 20 minus 20 is equal to 0, suddenly drop to 0, then bending moment 0, 0, 0. Simply supported beam with external moment. Shown in figure. Draw the shear force and bending moment diagram. Firstly, find the support reactions R1, R2. R1 plus R2 is equal to 0. Take moment about this point. Consider clockwise direction positive. Therefore, this is the clockwise 16 plus 16. R2 into 8, actually anti-clockwise. Therefore, minus, they are equal to 0. R2 is equal to 2 kilonewton. R1 is equal to minus 2 kilonewton. That means R1 acting downward plus 2 kilonewton. Or otherwise, we can say upward direction minus 2 kilonewton. Support reaction minus 2, plus 2. Let us see the shear force diagram. Shear force diagram, this is upward force, therefore plus, but value is minus, therefore minus 2 here, minus 2, minus 2, minus 2. There are no load up to here, minus 2. Shear force diagram. Bending moment diagram, this is the external pin support, therefore bending moment 0 here, 0 plus this area minus, therefore 0 plus minus 8 is equal to minus 8. Here bending moment jumped due to the external moment. This is the clockwise external moment 16, therefore minus 8 plus 16 equal to plus 8. Again, plus 8 plus this area is equal to this bending moment. Plus 8 plus minus 8, 8 minus 8 equal to 0. Bending moment here. Otherwise, we can say directly this is external pin support, therefore bending moment 0. This is a checking purpose. Simply supported beam shown in figure. Firstly, find the support reactions R1, R2. R1 plus R2 is equal to 30 kilonewton. Take moment about this point is equal to 0. Consider clockwise direction positive. Therefore, plus 20. Here plus 20. This 30 into 4 also clockwise direction. 30 into 4. And R2 into 8 is anti-clockwise, therefore minus is equal to 0. R2 is equal to 20 kilonewton. R1 is equal to 10 kilonewton. Let us consider shear force diagram. Here 10 kilonewton upward direction, therefore plus 10 according to the shortcut technique, plus 10, plus 10, plus 10, plus 10. There are no loads, plus 10, plus 10. Here downward 30 kilonewton, 10 minus 30 is equal to minus 20, suddenly drop to minus 20. Again minus, there are no loads, minus 20, minus 20, minus 20 up to here. Bending moment diagram, this is an external pin support, therefore bending moment at this point 0. Then this bending moment 0 plus this area is equal to this bending moment. 0 plus 10 into 2 is equal to 20 kilonewton meter. At this point, there is an external moment, clockwise direction plus 20, therefore 20 clockwise direction plus 20 is equal to 40. Here jumped. Again, this 40 plus this area is equal to this bending moment. 40 plus this area is equal to this bending moment. Again, this bending moment plus this area is equal to this bending moment. 60 plus this minus area, therefore 60 minus 40 is equal to plus 20 here. This point, this is an external moment, clockwise direction plus 20. Therefore 20 plus 20 is equal to 40 Again, this 40 plus this area is equal to this bending moment. For checking purpose, you already know this is the external pin support, external roller support. Therefore, this is a bending moment 0. 40 minus 40 is equal to 0. That's okay. Let us consider this load arrangement. This is a beam, 40 kilonewton acting like that. We are able to simplify this load arrangement as like that. This 40 kilonewton acting at A with external moment 40 into 0.5, that is 20 kilonewton meter, like that. Question: simply supported beam shown in figure. We can simplify this arrangement like that. Draw the shear force and bending moment diagram. Firstly, find the support reactions R1, R2. Upward direction positive, consider R1 plus R2 minus, this is a load arrangement, this area 20 into 2 minus downward minus 20 into 2. This is the downward point load 40, therefore minus 40 is equal to 0. Therefore R1 plus R2 is equal to 80. Take moment about this point equal to 0. Firstly, consider this area 20 into 2, this area, distance, centroid distance 1 meter. Therefore 20 into 2 is the load into 1 meter. Clockwise direction, clockwise moment, therefore positive, plus this is the clockwise 20 kilonewton meter, 20 plus 20, 40 into 3 clockwise moment, 40 into 3 plus R2 into 4 anti-clockwise moment, R2 into 4, therefore minus here is equal to 0. R2 is equal to 45 kilonewton, R1 is equal to 35 kilonewton. Shear force diagram. This one upward direction 35 plus 35. This is downward for 20 into 2, 40 downward, therefore minus 40. 35 minus 40 is equal to shear force at this point minus 5. 35 minus 40 minus 5. Minus 5 here, there are no loads, minus 5, minus 5, minus 5. Here again downward force, therefore minus 40. Minus 5, minus 40, minus 45. There are no loads, minus 45, minus 45 up to here. Before consider the bending moment diagram, we should know this distance. Consider this one x, therefore this one 2 minus x. Apply the tan theta for large triangle and small triangle. Tan theta is equal to 35 over x. Here tan theta is equal to 5 over 2 minus x. Both are equal. Therefore x is equal to 1.75 meter. This is 1.75 meter. Therefore 0.25 meter. Now consider the bending moment diagram. This is external pin support, therefore bending moment 0. Zero plus this area equal to this bending moment. This bending moment plus this area is equal to, actually this area minus, therefore minus is equal to this bending. Again, this bending moment plus this area is equal to this bending. Area minus, therefore minus. Here, external moment 25 clockwise, therefore plus 20 is equal to 45 here. 45 bending moment. Again, this 45 plus this area is equal to this bending moment. That should be 0. Checking purpose. 45 plus this area minus, therefore minus. 45 minus 45. 45 into 1. 0. Then OK. Some observation. This external pin support. This one external roller, therefore bending moment 0 here and here. This portion UDL load, therefore bending moment diagram in parabolic shape, y is equal to minus x squared shape. Here to here parabolic. Here shear force 0. Shear force 0, therefore turning point, that point turning point in bending moment diagram, maximum here. This is an external moment, therefore bending moment diagram jumped vertically. This portion no UDL, therefore bending moment diagram inclined straight lines. This portion UDL, therefore parabolic shape. Once again, this is a shortcut technique of shear force diagram. Consider LHS to RHS here to here. So upward force positive, downward force negative. Therefore, this one plus upward plus A, upward plus A plus A plus A plus A. Here downward B, therefore minus B, therefore A, here A minus B. A minus, there are no loads, therefore A minus B, A minus B. Up to here A minus B. In UDL case, the area of the UDL diagram is the force. Therefore, this one A minus B, this area is A1. Downward, therefore minus A1. Here A minus B, therefore this shear force A minus B minus A1. There are no load. Therefore, here A minus B minus A1. Up to here A minus B minus A1. Again, this is the upward point load. Therefore, this one plus C. Therefore, here A minus B minus A1 plus C. And continue like that. If you consider RHS to LHS, here to here, careful, upward force negative, downward force positive. Better to use this one, LHS to RHS. Once again, this is a shortcut technique of bending moment diagram. We consider this a non-bending moment M1, already known. Therefore, this is a bending moment diagram. This one M1. M1. This is a shear force diagram. here external moment m0, applied point. This is a shear force diagram. Therefore, this bending moment m1 plus this area equal to this bending moment. m1 plus a1 is equal to m1 plus a1. Consider LHS to RHS. Go like that. Here bending moment diagram jump due to the external moment. This is a clockwise moment. Therefore, m1 plus a1 jump by m0 plus m0. Therefore, m1 plus a1 plus m0 here bending moment. After that, this bending moment plus this area is equal to this bending moment. Now, consider same example. This is our sign convention. Find the shear force and bending moment at y by basic procedure and compare with the shortcut method result. Now find the bending moment and shear force by first principle and check with shortcut result. Firstly, cut at y, consider LHS and RHS part. Apply the sign convention, and by equilibrium equation we can find the shear force and bending moment, but take time. Okay, cut at y, this is a LHS part, this is a RHS part. Apply the sign convention. Our sign convention for LHS, this one. Our sign convention for RHS, this one. Check. You consider LHS or RHS. I think LHS easy. I consider LHS part. By equilibrium equation, find the M and V. Consider LHS or RHS. This case I consider LHS. By equilibrium equation, upward force equal to 0 is 35. This is a UDL diagram. Area of UDL diagram 20 into 2, 40. 35 minus 20 into 2 because this one downward. The V also downward, minus V is equal to 0. Therefore, V is equal to minus 5 kilonewton. Shear force minus 5 kilonewton at Y. Consider, take moment about this point is equal to 0. Take moment about this point is equal to 0. Equilibrium equation. Clockwise, consider clockwise positive. Therefore, 35 into 2, that's one clockwise moment, 35 into 2 plus this moment, this is the area 20 into 2, centroid distance 1 meter. Here 20 into 2 into 1 meter. This is anti-clockwise, therefore minus. Here this is the anti-clockwise moment, therefore minus M plus V into here distance 0, therefore 0 is equal to 0. M is equal to 30 kilonewton. Therefore, bending moment at Y is equal to 30 kilonewton. Check with previous result. This is an actual method. Here Y, shear force minus 5, bending moment 30. Same answer. Once again, same example. Find the bending moment at this point. This point just after moment applied point. Here, RHS side, Z, only bending moment. Find the bending moment at Z by basic procedure and compare with the shortcut result. Cut here. Better to that is a RHS is easier than LHS. Here cut it and see this part. Cut it. This is RHS part. Therefore, apply this sign convention. Use the equilibrium equation. Find the bending moment. Here bending moment. Therefore, moment take this point 0. Clockwise consider 0. Here clockwise m plus m. Here 45 into 1 anti-clockwise, therefore minus 45. V into 0, 0, therefore no need. is equal to 0. M is equal to 45 kilonewton. Therefore, bending moment at Z is equal to 45 kilonewton. Check. Here bending moment at Y just after here LHS value, this one RHS value. Here 45, same answer. Thank you.